this little area is called the hilum. So the hilum of an organ is usually where structures enter. And so it's just like a anatomical area. It's just a name for where the bronchi are going to enter into the lungs. Okay. And so every single lung is going to have pleura. All right. So you have parietal pleura and visceral pleura. And so let's draw these in orange here. So the parietal pleura is kind of an outside sac around your lungs. All right, so we're going to just draw an outside sac. And so we're going to label this the parietal pleura. And then touching the lung itself, we'll draw this in purple. This is where the visceral pleura is at. And so it literally lines the surface of your lungs like this. Okay, so this brings up an important point. If we're talking about structures in the body, parietal always means more outer, and visceral means more inner. Okay, so the visceral pleura is lining more inner on the surface of the actual lung. So if you're touching a lung, like you literally just pick up somebody's lung in the cadaver lab, you would be touching where that visceral pleura would be touching. All right, but the parietal pleura, that's basically an outer pleura. So that's going to be on the outside surface of the lungs. And so what happens is if you have like a lung collapse, what happens then is the visceral pleura is going to shrink inwards, and the parietal pleura, it stays attached to the chest wall. Okay, so that's something that you should know is if the lung collapses for any kind of reason, then it's going to be actually the visceral pleura that shrinks inward. Okay, so I'll just make that into a note here. So I'll say shrinks in with lung during collapse. Okay, and so inside of these pleura, you have some kind of fluid. They call it serous pleural fluid. And so what that is it's basically lubrication so that the tissues of your lung can rub and not get stuck on each other. Okay, so when you inhale, your lung has to expand, obviously. And so this pleural fluid, what it does is it basically decreases the surface tension of the lung itself. So it's able to expand better and so that it doesn't get stuck whenever it's expanding inside your chest wall. Okay, so that in a nutshell is your lung. And you have a structure on your left lung that I want to point out, and that's called your lingula. It's kind of like a little lip right here on your left lung. So that's called your lingula. And how I remember that is the L for lingula stands for L for left lung. All right, and your right lung does not have that. All right, so your left lung is split up into two parts. You have two lobes basically, and your right lung is split up into three lobes. Okay, so you're gonna have three lobes on the right, two lobes on the left, but the left has the lingula. So remember, LL for left has the lingula. And what happens when your primary bronchi or your main bronchi right here, what happens when they enter the hilum of the lung? So when they enter the hilum of the lung, they start dividing, and then they divide like 10, 20, 30 times. Okay, so let's just talk about these divisions. Okay, so let's just go down a little bit just for the sake of space. So here's your trachea. Remember, this is your windpipe. So this is where air comes into your body. Trachea is going to split into, we'll say, primary bronchi. Well, some places will call them main bronchi. All right, so then these primary bronchi are going to split into secondary bronchi. All right, and then what do you think secondary bronchi split into? They split into tertiary bronchi. Okay, so just a quick quiz here. Which side has the lingula and which side has three lobes? So the lingula is on the left, the three lobes would be on the right lung. Okay, and so these tertiary bronchi, I'm oversimplifying what it would actually look like, obviously, because they're going to split up like 10 or 20 more times. And eventually, you're going to get down to something called a terminal bronchiole. So we're going to just draw some divisions in here so you guys can draw in some divisions. And then eventually now, you're at your terminal bronchioles. All right, so there's something important to know about these. these are actually the last part to contain cartilage. So the last part of your respiratory tree, we'll say respiratory tract, to have cartilage. All right, so what happens after that? After the terminal bronchiole, now you're at your respiratory bronchioles. So these respiratory bronchioles are important because this is the first area where you can actually have gas exchange. All right, so I'll say first area where gas exchange occurs. All right, and so you guys have probably heard of alveoli before. So the alveoli is the major thing that does gas exchange, but the respiratory bronchioles can help them a little bit. All right, and so the respiratory bronchioles are what house the alveoli. So the alveoli are a bunch of sacs at the end of the respiratory bronchioles. So I'll say alveoli. These are going to be for gas exchange primarily. All right, and so at these alveoli, you got tiny little blood vessels. All right, and so you got these little capillaries that get all the gas from the alveoli, and then they exchange the carbon dioxide so that you can breathe it outwards. Okay, so one thing I want to mention here is what's the difference between a pulmonary artery and a pulmonary vein? So if you guys remember from other anatomy classes that you've had before, arteries usually have oxygenated blood. Usually. This is the one exception. Okay, so I'm going to just put a star by this because this is high yield. The pulmonary artery is one artery that is poorly deoxygenated. All right, well, whereas the pulmonary veins are veins that are actually oxygenated. All right, so that's against the normal, because usually if you hear a vein, you're thinking, oh, that's basically it's a little blood vessel that has no oxygen in it because it's taking away all the used up blood. But the pulmonary circulation is the opposite of what you'd expect. Okay, so let's just think about why. Why is this different? So a good mnemonic here is arteries take blood away. So remember, A goes with A. So arteries take away from the heart. Okay, and so let's just draw your heart. So right atrium, right ventricle, left ventricle. All right, so coming from your right ventricle, you have the pulmonary artery. All right, and so the pulmonary artery is going to take the blood to your lungs. So let's draw in your lungs here. And we'll just, obviously this is not anatomically correct here, but this is to illustrate a point. So the pulmonary artery takes the used up blood to the lungs. And then the pulmonary vein is going to take the oxygenated blood to your left atrium. All right, so we're going to say the pulmonary vein has a high amount of oxygen because it's already went to the lungs. The pulmonary artery has a low amount of oxygen because it's taking all the heart's used up blood from the rest of your circulation to the lungs. Okay, so make sure you know that. Pulmonary artery, again, is deoxygenated because it's taking the used up blood to the lungs. Pulmonary vein has high oxygen because it's taking the blood from the lungs back to the heart so your body can circulate it.